Hello again. I am Árpád Figyelmesi, the Markus product owner, and my presentation partner is Daniel Bonio, the product owner of naming technology. And we want to show you our new tool, the ChemCurator. Mickey yesterday mentioned or showed us his small, lovely baby. We also have a small, lovely baby. This is the ChemCurator. First of all, some words about the background of this development. It was a strong collaboration with some evaluator partners. And after the early discussions, we find there is knowing the chemical space covered by competitors' patents is absolutely essential for successful drug discovery. This information can be useful for ID generation phase, for lead candidate selection, drug design, or creating your own patents. But there are many challenges related to this area. The existing databases, mainly from the Markus perspective, it's designed for document searching, and the chemical content is not accurate enough for medicinal chemist needs. The manual processing of patent documents is possible, but it's a really time-consuming task and needs special expertise. Automatic processing is also available, but the quality is not so good. And there is a lot of visualization problems related mainly to Markus chemical space. Our answer for these challenges, the computer-assisted data extraction. This new technology based on some existing Chemaxon capabilities. For example, the English, Chinese, and Japanese name-to-structure, which can dramatically speed up the extraction process. The Markus editor, which can help you to create complex patent Markus structures. The structure checker and the Markus validation against the exemplified structures, which can guarantee the consistency and quality of the extracted data. And all of them based on our search and representation capabilities. But the heart of this new tool, the name-to-structure, and Daniel will demonstrate it for you.
Okay.
Thank you.
Thank you. So yes, one of the core components for this is the name-to-structure. So what does it do? Well, there are several kinds of names that it can support. So the first nomenclature is the common and drug names, like aspirin, etc. So this is based on dictionaries that we are compiling based on several sources, and we are trying to resolve the mistakes or the ambiguities from different dictionaries. So that's one kind. The other kind is the IUPAC names, and in general the systematic names. And so these are especially important for the exemplified structures and the R-group fragments of the patents. So if you have been looking at patents, you know that this is where the real meat of the patent is in terms of chemical names. So it's really essential to have these components. And so at Chemaxon we have name-to-structure since 2008 in English, and that was Marvin 5.1. And much more recently, we added 2 more languages, which is Chinese last year and Japanese this year. So you can ask the question, why did we go into Chinese and Japanese? This is why. This is a graph that shows you the evolution of how many patents were submitted every year in different offices in the world. So the first, well, if you look at the yellow line, this is the English patents, so USPTO, and you can see that it has been growing steadily, as is probably not very surprising. Maybe slightly more surprising, if you look at the one that's in dark red, that's the Japanese. So it actually used to be the office with the most patent filed in the world for many years, and it's been kind of flat or slightly going down recently, but actually it's more technicality. So the Japanese patent office encouraged or requested that companies would not stop filing several patents for related inventions, but a single one which is bigger. And so it means that the number of patents is slightly less, but the amount of chemistry that is there is the same or more. So definitely this shows that Japanese is important language to cover as well as English. But of course, there is one graph which here is very like, crashing the screen. This is the red one. And it's not only because it's red, but because the number is growing, it looks exponentially, and this is China. So what you can see is that basically 20 years ago, there was even not a patent office in China, and since it appeared, the last few years it has been exploding, to the point that since 2 years ago, there are more Chinese patents than English patents coming up every year. And so because of this, it was quite clear for us that we should go in that direction. Okay, it's one thing that we can say we have English, we have Chinese, we have Japanese. How well does it do? It's not enough to just have it. It should actually find most of the chemistry. So we are doing several kinds of evaluations constantly to validate that what we are doing is correct. And I want to show you one example. There are different ways we do this, but this is one of them. In this case, what we wanted to do is to measure the quality of Chinese. And it's, of course, measuring our tool, but it's also measuring the quality of the data. So we have two options when we want to validate. We could do a small set of patterns and look at it manually, compare the results. And that has advantages because the manual checking can be very precise, but obviously it's very labor intensive, and it means that you will have a small amount of data. So you might have wrong results just because you were on a very good patent or very bad. So we tried to do an automated solution. And so the idea here is not just looking at one patent, but looking at a family of patents. So in this case, we looked for patents that exist both, but we have the data both in English and Chinese. And then what we can do, because our English is more mature, and we can assume that we have most of the chemistry in English. We just want to measure how much of these do we also find in the Chinese. So it's an overlap measurement. So if we get 100%, it means that every single structure we had in English, we also found in Chinese. And that would be the best result. Now, let's go to reality. I'm showing you different techniques and different data. So this is slightly complex. I will take the time to explain this slide especially. And I hope it will be understandable. So we have two lines, which are two different techniques you could use if you want to get chemistry from, for instance, Chinese or another language. What you can do is first translate this language into English, and then you can use your usual English name-to-structure tool. And the translation could be done by any software, or maybe a provider that will do this for you. So that's one technique. Second technique is to go directly to the Chinese language data, and then you need to have a Chinese name-to-structure. Now that we have these two techniques, let's look at different data that we can use. So the first one, we got a sample from one of the patent providers. Wanted to evaluate how is it going. So we got both the Chinese and the translated English. So now what you need to know is that this Chinese already is the result of OCR. So you know that OCR in English is quite good but not perfect. You can imagine how it is in Chinese. It's even more challenging. And so you have the Chinese data, which is OCR'd, and then you have the translation of this into English. And so you add up some errors in the OCR plus more errors in the translation. The result of this is that if you look at the translated English in this data set, you will get 1% overlap. So this is catastrophic. There's no other word. Just because the errors are piling up. And a small error in the OCR will be completely confusing the translator. If we do directly the work on the Chinese text, then we can already get, it's much better, or it's much more because it's 13%, but that's still really not acceptable. So what else can we do? What we could do is to extend our OCR error correction, which we do in English, into Chinese. So it will be a different algorithm because the errors are typically different. So Chinese characters, there are less of them, they have more meaning, and they are more complex. So obviously there will be errors that are just characters that look slightly similar in Chinese, but have entirely different meaning will appear. where we are lucky is that because we are doing only the chemistry, this is the part relevant for us, then if we get a character which is absolutely can never appear in the chemical name, but we know statistically we can discover those that are, so those that are very frequent, where it looks like it should be a chemical name, but this character doesn't make sense here, then automatically we can detect it, and then manually we can say, actually it's that one. And we actually have a quite interesting name when the character for phenyl looks very much like the character for stupid. So you have a lot of IUPAC names that have stupid ill in the middle of them. And so this is something we can fix. So by doing this, well, you get no improvement in English because it is not relevant. The translation is already done. But if you do it in Chinese, we actually go from 13 to 23. So it's almost doubled, it's better, but it's still not good enough, far from it. So the lesson from this is that you really need to make sure that your data that you start with is good enough, otherwise whatever you try to do with it, there will be too many errors. So luckily we had a last set of data which was a bit smaller, but we knew that we actually got it directly from the Chinese Patent Office. And this is probably choose a good OCR, and I think they're already also hiring people to improve. And what we could see is that finally we get some reasonable results. So if we take this Chinese text, which is better quality, and we translate it into English, in this case we use Google Translate, we could get 43% of overlap. So it's, again, once more, significantly more, but it's still not good enough. And finally, if we go directly using our Chinese name to structure on this, better data, then we got 83% overlap. So that's the first number that doesn't look completely ridiculous. It's not yet perfect, but it starts to be good enough that you can get a good impression about what kind of chemistry is in the patent. So again, one message is that you should really pay attention to the quality of your data. And I know that the patent providers are working on it, and I think it's improving. OCR error correction can help. And also, you probably need a Chinese name to structure, because as soon as you use a translation, automated translation with a generic tool, you will lose a lot of it. So we got finally to this 83 number. So as I said, it's starting to be good enough, but at least for some patents that you might have found using these automated methods, you probably want to go to the next level. We hope to improve, of course, our automated method and maybe get to 90 or 95. There will be a point where you won't get to 100. So what if you actually, you know that this patent is very relevant for you? Something I must mention is because of the volume, how many patents there are, you are not going to manually look at all of them. So you need this automated tool. But once you find the relevant ones, you might want to go to 100. And so what do you do here? You need to help a little bit the system. And so one more tool that we can offer for this is what we are talking about now. And the next component is, now that you want to actually look at the patent, what we can provide is a visual representation of this patent. So typically, from a patent provider or patent office, you will get an XML, which is very good for computers, but it's not very friendly for chemists or for end users, right? So this document annotation is going to turn this XML into HTML that you can actually view in a browser or in a desktop tool. And it will also highlight what are the names that were found. And so this is something that is ready for human usage. I just show you some of the interesting things that's happening in Chinese, because they typically don't use spaces between the words. So in this case, you have these 3 in Roman letters, -4, and this is something like a paragraph number. And then right after that, you have N, which is the start of IUPAC name, like N. I can't read that well. Maybe David could. What is this? Yeah, like the beginning, this part. And in English? Okay, it's good enough. So actually, I'm sorry about it, David. It was not planned. Okay, so actually you don't need to know, because you have the chemical structure here, and you could even translate it to English. So you probably understand this part much better than this, right? So yeah, here we have some special algorithm that is needed to find where the name starts and ends, and it's quite challenging, but it's working relatively well already. And so now we have this document annotation, and I will give back the word to Arpi, who will show how this is used in an end-user tool.
Thank you. In the early phase of the development, the document annotator was the only missing component to build up a software which can support the workflow what our users want. They want to collect, if they start a drug discovery project, they want to collect the relevant patent document related to the target area. It's usually less than 20 documents. And with a curation tool, information scientists or IP professionals can represent the chemical content of this document in a very precise way under reasonable time. And they create a high-quality, project-specific database which can contain the Marcus structures from this document, the compounds, the original document, annotated version of the original component, and linking between this document and the extracted information, and obviously the assay data related to the compounds. This database can be used in drug discovery process through IGC or Plexus or any third-party tools. This offers new opportunities, less risk, faster communication between the participants of the drug discovery team. Here you can see the UI of the application. This is we have two extraction views, one for compounds and other for Marcus structures. This is the compounds extraction view. In the middle of the screen, you can see the annotated document. Chemical information is highlighted by gray. Maybe it's not the best color for it. And if you can select on this document, and selected structures appears under that, this selected structures view. You can simply drag and drop the structures from this view to the editor components, in this case, the compound list. Obviously, you can add additional fields to this grid. For example, if you want to add is claimed or not, you can simply do that, or if you want any comment, you can simply add a new field to do that. This project explorer representing the project hierarchy. Every project is representing one curated document, and you can add as many Marcus structure and as many compound lists to this curated project as you want. Under the Marcus structures, you can see exemplify structures list. It's automatically generated. Related to Marcus structures I mentioned, we have another view. This is the Marcus extraction view. This is a good example how can you use the Marcus editor as a component in another application. As you can see, this part of the application is quite similar, but here you can see the Marcus editor, and under that, the exemplify structure list. The same way as you can drag and drop structures from the document selected structures view to the compound list, the same way you can drag and drop fragments from the document to the Marcus editor parts. And if you add exemplify structures under this view, these exemplify structures are continuously validated against the Marcus structures. That means the structures highlighted by green is matched to the Marcus structures, but the structures highlighted by red is not matching. That means some kind of inconsistency of your extracted data. This is a really fast feedback for the curator. The extracted information is right or not. If you select any of these matching structures, we can highlight what is the matching part in the Marcus. But if you select the red ones, we can't say anything currently. That's what I was mentioned in my previous presentation. We want to implement a non-hit highlighting functionality, which can help in these cases and shows you what is the problematic part of your Marcus. Why is not matching to the structures? This can save a lot of time for the curator because it's really hard to find some cases in complicated Marcus structure. What is the mistake in your drawing? I have a short demo about the basic usage of this tool. You can import documents from many sources. I use here a simple import from Google Patents. We have an integrated version. You need only the patent number to do that. The draw structure is not recognized here because I run the annotation without Clyde. But if you have installed Clyde or Ozra, the structure is also highlighted. I add an empty Marcus structure to this project, and I draw the scaffold. Be careful because I a little bit cheat here, if I remember well. Yes. This way, you can very easily draw the structures. And as I mentioned, you can simply select the fragment definitions and drag and drop in the same way. Let's find someone. Obviously, the recognition is not perfect. But Daniel just mentioned me before the presentation is much better now. He can add the attachment points automatically. It's not necessary anymore in some cases. OK. The same way, you can drag and drop the exemplify structures. Or we have some extraction wizard, which can help you to find it automatically. But now I do it manually. I finished it. And as you can see, it's validated against the Marcus structures. This is the two-way linking between the document and the extracted information. If you select any of these exemplify structures or fragment definition, what is extracted, the document view scrolling automatically to the relevant part of the document, and you can inspect the context of this information. I think it can be really useful to understanding better the content of the document. As I mentioned, we have a compounds view. I opened here the exemplify structures. This navigation function is also available here. And as I mentioned, you can add additional fields. I add a Boolean field here. It's claimed or not in the document. It's a simple checkbox field. You can check it on sometimes. Obviously, this is not a correct curation. And I add a text field containing some free comment related to this document. We hope it's quite intuitive and easy to use tool for this purpose. And as we know, it's absolutely unique on the market. Nobody has similar systems. Daniel?
OK, so let's step back for a minute. What we have shown you until now, basically, we were only talking about patents. And obviously, I think there are quite a few of you here who are dealing with those patents, and they know how challenging it is. So we hope this is a great tool for this. And as we were developing this tool, we actually called it the patent curation tool. That's the whole name of it. But at some point, we realized, wait a minute. If we can do this for patents, we can actually do it for other kinds of documents, not just patents. So we can do for journal articles and internal reports, and of course also the patents. So it's just one of the cases. And so we want to stress this, that this is something that you can use in different ways. It actually has modes. So now I want to stress that you can use ClaimCurator for any kind of document in which you know that there will be some structures that will be present, and that you would like to visualize this document, see where the structures are, in which context they appear, and maybe fix OCR errors or select which ones you want to export. So basically do an interactive extraction of the structures. So for those of you who have been using document to structure, which basically is an automated tool, now you have a graphical user interface for it, which is much better than anything we had until now, because it's really specific for documents. And you can do all these nice things with selecting the structures and also the wizards. So the wizards are there to handle the problem of noise. So people told us, oh, it's quite nice what you can find in a document, but there are lots of things which are not relevant for us. Maybe there are all these fragments, methyl, ethyl, phenyl, hydroxyalkyl. I don't want these parts. Some people need it, and if you want to build a Marcus, you need it. But in other use cases, you don't need that part. And if you get a list of these, which can be hundreds, it's very annoying. So we have a wizard that can filter these. Also, fragments maybe the solvents are not relevant for you. So Wizard is there to allow you to customize what you want to extract. So this tool supports a lot of different formats. So if you have a local file on your hard drive, which is an XML or PDF or HTML, then you can just open it using ChemCurator, file open, you know, the usual stuff, and it will come up. Something I want to stress is that currently we don't support Office formats in this tool because we are not sure if that's actually relevant. So if you are interested in doing something similar to this on Office documents, please talk to us and we will understand how you want to use it. We have kind of two ideas. One of them will be to support it here, and we need a little bit of work, but we know it's doable. Another option will be to do this in JChem for Office. So that will be kind of a different workflow. So we need to talk to you if you want that, and we will decide which way we want to go. So that's one way for all the files. Now, if you want to work especially on the patterns, obviously you can have the pattern as a PDF, but typically as a PDF. That's what most people do, and that's fine. We can do it. But maybe wouldn't it be nice if you can just type patent number, and then the tool will find a patent for you. So that's what you can do. So there are several options for that. One of them is to download, given a patent number, the tool will go to Google Patents, find this patent, and download it for you. That's one way, and it's quite practical. There are some concerns with that as well. Some people were saying to us, we are not sure from a legal point of view or confidentiality point of view if we are happy to do it like that. So we actually have been working on different ways. So obviously they can do the PDF way, or we actually integrate it. So we have a partnership with IFI Claims, and Rosa from IFI is here with us. So if you have a subscription, so IFI is a patent provider, and if you have a subscription with them, then you can just enter your login information in ChemCurator, and then you will use IFI provider to download the patent. So it might be, maybe your legal department will be happier with that. You need to talk with them, but that's an interesting alternative way to do it. And if you are interested in this kind of usage to get the patents from IFI, then I encourage you to talk to Rosa, or you can talk to us and we will introduce you about what are the benefits of this approach. Finally, the last thing we support is images, so structure images in the documents. So typically they will be in the PDF or linked from the HTML or the XML. So for this, we support third-party tools that will do the optical structure recognition. So there is Osra, which a lot of people probably know, and it's an open source tool. You do need now to pay a small token fee for the installation, but I think you can pay it once and install globally. The other option is Clyde, which is a commercial product. Several people who tried it said that it has very good quality, and it has a faster processing. None of them will be perfect, but we actually can resell Clyde, and so we can offer you a package with Patent Curator and Clyde. So if you want to try, I encourage you to compare both and see what works for you.
Okay, I speed up because Doug looks angry. Okay, ChemCurator is a good desktop tool, but a desktop tool alone is not really useful. Because we implemented some integration features. Through the integration server of ChemCurator, you can share the curated project inside your company with other ChemCurator users. And from the integration database, you can also access to this kind of curated data from other Chemaxon tools. It uses a standard IJC schema, and it's widely supported by Chemaxon applications. Because we use mainly standard file formats, for example, SDS, HTML, XML, the project files is also can be processed by external tools, third-party tools, if you want to use your own applications. We have some plans for further improvements. For example, in the naming side, we want to improve the accuracy, as Daniel mentioned, and we want to add new languages. From ChemCurator side, We want to improve the processing. We want to implement a pre-processing engine which can generate a raw project for you from bulk downloads. And we also want to implement the non-hit visualization, what I mentioned previously. And we're working on some Marcus extraction wizard to speed up the Marcus extraction process as we can do. Okay. Finally, I say a special thank for our external partner, the Key Module and IFI claims, and personally from Rosa. And I also want to say thank you for the early evaluators who can help us with their feedbacks and very good ideas, especially for Xingwei. He helped us a lot in the development phase. If you have any question, please let us know or write it in this support address. And I think the application is available now in our homepage. You can download it and try it yourself. Thank you very much.
So this is really great, but I'm wondering what the extent of your fragment recognition is, because people will put in things like C1 through C8 alkyl. Will you catch that? And then what do you do with things like the infamous optionally substituted heterocycle?
No. So yes and no.
Okay.
Yeah, at some point people use natural language, so there is something that you will need somebody to look at. What we are trying to do more and more, so there are some kind of fragments that I said that something improved today and there are more that will come, but definitely, and people even said that it's on purpose, that it's not possible to do it automatically.
A question, what about managing the collection of patterns of documents and queue them into database format, whatever the result gonna be, then have some like a core structure-oriented project to search in the whole collection other than one document at a time?
You want to use only the core structures in this project? You can extract only the core structures. It's absolutely available. No. If you don't want to extract the rest of this information, it's not necessary. It's your choice.
Well, that requires the accuracy result to be put into a database so you can do some future search.
This search of this information is also available. You can, if you extract only the core structures, you can put it in some query table, and this way you can search it. It's available options in our other tools.
A quick question. You mentioned a couple of times on the naming correction. I mean, it's very notorious for the OCR quality. Like a typical case, I gave you one. YL become 1L. Imidazole, M become IN. So I didn't see any, well, probably we can talk later, but I really want to see a systematic algorithm to fixing those. And the early point you mentioned is a very good point. When you make the fixing, do you build a local dictionary? Like for one patent, in the beginning, you see the good ones, and keep those and then matching it up so that you're not drifting away when you do the naming checking. The naming checking is so notoriously bad, but unfortunately, all the good structures is from WO patents, and the quality of OCR is so bad. I can give you a challenge. I can send you a patent if you can get 50% right. Seriously.
Right.
So
yes.
can you, I mean, it's not taking rocket science. Like 1L become YL become 1L. It's a typical bracket become curly. It just kills you.
Yes. So
it's not I trust your name to structure conversion. Once you fix that error, everything flies. That's really the bottom line.
That's the easy ones that you start with because they are very frequent, and then there's a long tail of other errors. But yeah, so we do correct the brackets. We do correct the L's and Y's and 0 and O.
Do you do increment correct until it fails, now becomes mechanical? Because the thing go really low.
Yes. So we do try to find the longest part that we can recognize as a chemical.
Well, you can publish
solve this problem forever?
It's not so forever. So we are going further in that, but there are still more cases. Yeah, so I would love to see this patent, and let's see how it goes. So we do, yeah, I mean, it's a good challenge. So we do have something, and yes, at some point, there is the long tail of very different or strange things or low quality patterns. So at some point, you get to the point where you might want to fix still by hand. But we do quite a lot already, and it keeps getting better.
Okay.
Yeah.
I have
Bring it on.
quick questions. Do you have any vision that it will be able to use that feature in the SharePoint too? SharePoint?
Yes, this question is come from many sides these last 2 days. Previously, we don't have any plans for that, but now we have.